All right, let's talk about this chart. This is with the understanding that you're using a standard carbine, right? Or the standard spring co. I forget the color. Or a tub flat wire. And the standard 5.56, not the short. Okay? All of these are typically where we start. If we have a choice, we actually prefer the tub. And I'll explain that in a little bit. But let's start off. A barrel that's less than 10.3 inches on a 223-5.56 is a no-go. Okay? Don't do it. All of this is no. Don't do it. It's not worth it. Don't even fuck with it. And a pistol length gas system in a 223-5.56 is dumbass land. It's complete craziness. So you're getting about 42 to 44,000 psi out of a pistol gas system with 223-5.56. That is insane amounts of gas pressure. So the original AR-15 was designed around a rifle length gas system, and those are usually in the 14 to 16,000 psi. Maybe even less. I've seen them as low as 12,000, and the system runs fine. So every time you get closer to that chamber, that pressure goes up a lot. And that pressure is no joke. That is half of the reason that we have all of the AR-15 VooDoo problems as it is. If we always ran rifle or mid-length gas systems, and that's all we did, well, you would find out really quick that 12.5 is kind of your happy place, and anything shorter than that's a waste of time. But we do go down to 10.3 inches. They do want to run reliable. Your dwell time at 10.3 is pretty much the smallest amount of dwell time you can have past your gas poured on the barrel and still have your system run reliably. And that is with the carbine gas system. We typically start out with an H2 in those systems. We also really want small gas ports. 0.070 inches on a gas port size is really optimized. Maybe 0.072 on the outside, okay? Because your dwell time is fairly short and having just a tiny little bit of gas helps. If you're running it suppressed, 0.070 is really your happy land, and that's not from me. That's actually from the millions of dollars we gave to companies from the U.S. government for NAV Spec to understand how small they can make a gun. That's MK18 program information, right? 11.5s. My personal opinion is that the dwell time difference, which is renowned to be 40% difference, is such a small amount of percentage in comparison to the actual numbers that you're using that it's essentially a 10.3 to 10.5 inch barrel. It falls into the same category. So dwell time, it's time. How much time are you getting before that bullet passes your gas port and leaves your barrel? That's your dwell time, okay? If I get 40% more, but my dwell time was horrifically small, is it significant enough to be like, fuck yeah, I gained everything? No. Percentages are a secondary representation of an actual measurement. And in this case, you're taking the measurement of a 10.3 to 10.5, and you're comparing it to an 11.5. This difference is 1 inch, but how much time are you getting? You are talking microseconds of time. It is almost insignificant. I've also heard, 10% longer life. I can't confirm that. So I treat all 10.3 to 11.5 when it comes to timing exactly the same, because your gas port size at that point could literally make it beneficial or non-beneficial, right? You will get more velocity out of the 11.5. That's the only thing that you can significantly say that's measurable and repeatable out of this scenario, is that your velocity will be a little bit faster out of the 11.5, period, okay? So we start off with our 10.3s to 12.5s almost exclusively with an H2. As that barrel gets longer with the carbine system, we start to lighten the load because our pressures are starting to drop a little bit since the bullet's traveling out a little bit further. And we can usually get away with H's on the longer guns. I don't recommend carbine systems on these longer systems. They work better on mids, okay? So this is optimized for the shorter barrels. this right here is your happy land, your mids for the 13.7s to 16s, okay? So let's do this. Let's hashtag these for what I would consider optimized gas lengths for those. Sorry about that. We closed at 3, the doors are still open, so I got interrupted there. So let's hashtag what I would consider optimized for those lengths, okay? Right here. And when I say optimized, I mean it's kind of that happy land. It's in the middle, so it's not what I would consider like a comp rig, and it's not what I would consider like a heavy duty, super reliable for feeding, longevity, shooting type combat rig, okay? And then the 18 plus is definitely carbine. So that's basically where I like them to fall. But if you have a bigger gas port, or you have in a very efficient bolt carrier group, then sometimes you may have to go up in weight or down in weight if it's less efficient to get the system to run optimally. So what do I mean optimally? It's bolt carrier speed, and how do you measure that? Well, like I briefly touched on before, you really can't. There's no true way to measure your bolt carrier speed except for measuring it under slow motion video and then doing the math to figure out its feet per second, inches per second, whatever, and then do comparative analysis to figure out, hey, this is giving me, out of all of these 50 guns, this is the one that gives me kind of the optimized location. And I ask this question a lot, especially on the Books of Faces and chat rooms, and nobody has an answer. What's the optimal speed for that bolt to be traveling to make everything run right? I don't think there's an answer. I think that your spectrum of okayness, right? So if we're looking at a spectrum line like here, okay? And here it's fast, and here it's slow. So everything beyond these 2 points is failure. I think that everything in here, for the most part, is an acceptable speed to a certain respect. The faster it goes, the more you have to account for worn out parts like cam pins and gas rings, okay? And probably you're eventually going to wear out your barrel faster, and you're going to wear out your bolt carrier group faster, or bolts faster, okay? Some situations that's acceptable, right? The slower you go, the closer you get to failure, and the more susceptible it is to failing with too much frictional loss if you don't have enough mass to overcome it. So there are advantages and disadvantages to this. Some systems, in my opinion, have a smaller acceptable range of timing based on failure rate, okay? Some systems are very, very forgiving for that. The 13.7 to 16 inches with the mid-length gas system, in my opinion, is the rock star. It gives you the most flexibility when it comes to your buffer weight, your buffer spring, the efficiency of energy that's going into your system, and still maintaining quality. So the 13.7 to 16 inch is where I recommend a lot of new shooters start at, because it gives them all of the flexibility when it comes to reliability and shooting. So this right here, this one right here is my rock star. That's where I'm really happy, and that's where I recommend a lot of people start out at, okay? That doesn't mean that these other ones can't be reliable. It means that this one gives me the largest margin for reliability. As soon as I go to a shorter system, I have a shorter dwell time, a higher gas pressure, and I start to lose that area of acceptability. Back here, there's some things that you can do mechanically because you have too much to restrict your gas and to restrict the efficiency and to heighten your resistance, and so they're easier to control. If I have too much in the system, I can do mechanical fixes to lower that. If I don't have enough in the system, I'm running a rifle with a carbine length buffer and the gas port is super small, I'm toast. I cannot add energy to that system anymore. The system is fixed and set at the minimum amount of energy that it's making, and I can't add it. Adjustable gas blocks will not fix this. Adjustable gas blocks will restrict, but not add. Okay? So these are easier actually to fix than here. Right here at the rifle with a carbine system or a carbine buffer weight or just a basic rifle system. If you don't have a big enough gas port and you're running really soft ammo, especially reloads that you're running soft just because you're trying to get, minimum size group at a competition or something, you can short stroke the gun and you'll have to open up your port to make the system run right. But this is Happy Land, and this is typically where I start out to try to get the system to be within respectable timing, acceptable timing, but not over buffer the shit out of it. So what happens when you over buffer the system is that you take your dot movement and you take the shootability of the gun and you push it to an area where you have to shoot it slower to get your hits. And some people are like, well, that's an acceptable exchange. I agree. You going into combat, that's an acceptable exchange. You're going into competition, it is not an acceptable exchange, especially if you're shooting competition a lot. At that point, that's when you invest in different parts and components to minimize that dot movement so that you can shoot the gun faster, okay? But this is an important chart. This is where we start at, okay? So, say you're shooting the gun and you start looking at ejection. So this is the muzzle, this is the buttstock, okay? This is your ejection port right here. So everybody has seen this in stuff before. This is your 3 o'clock. And you really are optimized technically from like the 3 to 4:30, okay? So this right here is Happy Land for ejection pattern. But that's optimized. What can you get away with? I think you can get away with this because I've seen it. So actually here, that's too much. So about 2 o'clock to, I would say, 4:30 is acceptable. It's going to run within this timing area depending upon the firearm. Why do I say that? Well, if I'm running a gun with and without a can, I want it optimized here, that 3 to 4:30, even 3 to 4 o'clock, okay? And then when I put that suppressor on it, I'm adding back pressure and it's making my system cycle and it's ejecting here. Now, here's the trick to this. You're gonna read, and it has been said over and over again correctly, that this is not a reliable form of patterning the gun's timing. That is absolutely correct. There are so many different mechanical pieces involved in the ejection pattern on an AR-15 that if you immediately shoot it like this, and you're like, oh, nope, it's out of timing, you are missing the ideology of this test. This test is done in a very specific manner. I take this gun and I take it out and I test it, right? And say it's a 14.556 pin and weld. I have no suppressor on it and I have an H buffer. And it's kicking out here. Okay? So this is where it's ejecting. Nope, it's too fast. I gotta fucking put a different buffer in there. Maybe. Did you slow motion video the ejection port side of the gun when you're doing this? The slow motion video will actually show you what's happening. Is the slow motion video showing you this? For 1 second I see it closed, the next second I see it closed and there's a cartridge coming out. Well, that's too fast. The slow motion video is showing this, bloop, clunk, and you can see it never went all the way to the back. It's too slow. Did you see this? I can see it coming back, I can see it coming forward. That's within spectrum. So a standard iPhone has 240 frames per second slow motion from the one side. I think it's both sides now, but it used to be 120 and 240. And you can look that up in your phone. There's a way to do that in the information section. Well, I want to take that 240 frames per second and I want to see, is it, I can't see it, right? It's short stroking and I can see it, or I can see all of it. If I can see all of it, it's probably within that spectrum of okay timing. And that's really why slow motion video is way more important than this. If I'm looking at this and I'm seeing that I'm almost to the point where I can't see it, yeah, that's probably too fast. But if I'm seeing this ejection pattern, but I can see the entire stroke, I'm probably okay within that timing. And it may be something like the extractor or the ejector need to be fiddled with a little bit to change the way that it's ejecting, or nothing at all. I have one gun that I can run everything from a carbine to an H3 and an A5 and a standard carbine, and it ejects at 3 o'clock. Period. All of them. Well, it's not magic, okay? It's physics. There's mechanical shit going on, and it's just so efficient and reliable that it kicks out at 3 o'clock all the time. But my slow motion video is also telling me that I have a huge spectrum in that, and it's all within that spectrum of okayness. So, look at your slow motion video in comparison to your ejection. Now, once you have a main line, okay, I did this. I did my H buffer, and I watched my slow-mo, and it says it's doing okay. Now let me put an H2 in there. Where is it ejecting? Is it back here? Okay, well, the H2 and the H, that's quite a jump. You have a perspective to weigh and measure what's truly going on, and maybe the H2 is a better system for that, unless you're using it and you're shooting it faster, and then the H is okay instead of the 2. If you're running a can on it and you're getting this, you definitely want to go to the H, because with the can, it's going to speed that system up and it's going to kick your ejection out at a faster pace, and you're definitely going to stay with the H2. If you're never going to use a can on it, it's a gamer gun or it's just a fun plinking gun, you don't own a suppressor, then fine, stay with the H. It's going to make it an easier to run system, and you're not going to bog it down with extra reciprocating mass and make it a harder gun to shoot and learn with and practice with. You might wear your gas rings out a little bit faster. They're $2.50 a set for Springcos. Wear them fuckers out. Go for it. Oh no, my cam pins wore out a little bit. I got to replace it. Sweet. That's what we like to see. We like to see people shooting their guns and wearing their parts out, because now we know that they're practicing, and that's really what it's about. It's about your skill level, not, oh my God, it's got to be ejecting at 330. Oh, it's not ejecting at 330. I'm going to lose my mind. And this is unfortunately what we see a lot of, because people don't understand that this is comparative. You have to have a main line. You have to have something to compare it against. This is my H, this is my H2. Now I have 2 to compare. If you're here and you get your H here and you get your H2 here, it's almost insignificant at that point. It doesn't matter. It's probably irrelevant on which one you run. And some of these systems, you'll see that. You'll see that they're running so well that the buffer weights, like in one gun specifically, I can run everything from a carbine to an H2 and it still operates. As soon as I put an H3 in it, it's a little bit too much. Another one, I can run an H2 and H3 and it runs and everything. Some of my other guns, like here, these are much more sensitive. I put a carbine in this thing and it's running like a raped ape. It's going to fail every time unless I use some sort of mechanical device to cut the gas back. So, short of some sort of mechanical device like an adjustable gas block, this is really kind of where we start out, right? So what are the factors that you have to look at to really optimize this system? Your gas port is your number one, right? So the gas port, if it's too big, you have to mechanically stop that extra gas from going through. There's a couple of different ways. One's an adjustable gas block, and the other one is a Black River Tactical adjusted gas tube that has a smaller port in it, okay? Your bolt carrier group. Is your bolt carrier group efficient or inefficient? So hopefully it's an efficient bolt carrier group, because it takes all of this changing out. if it's a super inefficient bolt carrier group and you don't have enough energy, you probably need to replace it with a better bolt carrier group that's more efficient. In other words, it's not leaking as much gas. The tolerances are tighter. It was made with better specifications. So if you have a BCG and it's too little gas, go get a microbest bolt and bolt carrier group. That is a BCM bolt or a Sons of Liberty bolt, or any other company that's using microbest. Those are the ones that we find are the most efficient right now, okay? The other thing that you can change, or the other thing that will affect it, is your buffer weight and your buffer spring, lastly. So your buffer weight is this is what we change the most, as you can see. And then the buffer spring, hardly ever. So we almost exclusively use the tubs. So the more coils you have in a spring, the more it's transferring that collapse and then that energy across those coils. So each coil is taking so much, theoretically, okay? If you want a carbine spring that has less coils to feel like a rifle spring, you have to have more coils in there to actually make it feel like a rifle spring, but make it fit into a carbine buffer. So what A5 system does is that it gives you enough spring length that you can actually use a rifle spring and still not collapse the spring on itself and coil bind on the inside of the buffer tube. What the tub does is the tub is a flat wire spring with a different material. It collapses that energy differently, and it doesn't spring bind in a carbine and still gives you the same amount of coils. So they're essentially, theoretically, doing the same thing to make this system run more efficiently and softer. It's just the tub can do it with a carbine tube and a carbine buffer, where the A5 system is doing it with a 3/4 of an inch longer buffer, and then you can go just to a standard rifle spring. Most people use the green springs from Spring Co. when they do that. I've tested them. It all comes back to reciprocating mass for me. And the A5 just simply has more reciprocating mass on average because it's a bigger system. And because of that, I actually find that a lighter carbine system with the tub spring has less movement in the gun as I'm shooting it than the A5 system. Now, if I was going to war, yeah, I'd probably look at the A5 system pretty hard, especially with like a Spring Co. or even a tub, because I'd want to maximize that efficiency for the most amount of time in the most adverse conditions. That's what I would do. And that's why this is VooDoo. It's a huge, huge topic. And you have to look at all of these different factors to figure out exactly where you want to go. But start here with your systems and then change the angles. Will this change with caliber? Hell yes. So the 300 blackout contract with AAC was I believe a 10.5 inch or a 10.3 with an H2 system in it. Why? Because it was for the military, it's for SOCOM. And they're trying to maximize the amount of time that thing can run in adverse conditions and still be reliable. Do you need an H2? What we find typically is that the port size on civilian-made firearms are a lot smaller, and if you put an H2 in there, it's going to short stroke on subsonic ammunition, which is a lot more anemic. So we usually start off with a carbine and a tub flat wire 300 blackout spring, and I can usually get them to cycle with and without a can, sonic to subsonic, in this entire spectrum right here, and it'll stay reliable. You have a huge spectrum on 300 blackout of reliability because the powder's different. You're using a Magnum pistol powder. You're not using rifle powders. 6.5 Grendel, 6 arc. Typically, I look one buffer weight up from these. And typically, you don't see these shorter lengths in those because those are longer distance calibers. All of mine are 18 plus. So my 6 arc is actually a rifle plus. It's a rifle plus 1, and I'm running a standard carbine in there, and that thing runs, no, actually I'm running an H, I'm running an H, because I'm running it suppressed, and so I went up one weight, and that thing ejects perfectly, and it will eject a little bit slower with the H in there, because it's ported correctly. I'm running a proof barrel, and it's bueno. Okay, so you get into the super calibers like 458 SOCOM, 450 Bushmaster, 375. I will tell you to call TACOM, or not TACOM. Hold on, let me look it up. Okay, so I looked it up. So your big calibers like 375 to 458. Whoops, 58. Call Tromix. And I recommend the Tromix barrels too because they're ported correctly. Your larger calibers, you really have to start paying attention. And quite frankly, since these things we typically see, they run on carbines. They run on carbine buffers on the carbine system because they're ported correctly, and you're not pushing a ton of pressure into the system with those calibers. Sometimes an H if you're running a suppressor, maybe an H2. Okay, but this is meant to be played with. If you're having problems with your system, I go to the range when I'm testing a gun with the entire spectrum of buffers and even more that I didn't talk about on here if I'm trying to figure out what the problem with the system is, to include additional parts and components to find out if I have something that's inefficient and or possibly even not operating properly, like an extra bolt carrier group that I know I can drop in there and test. And then I go out and I test it. I get a baseline based off of this, and then I set up the buffer and spring based on what's running the best, including slow motion video. Okay? And that, in a nutshell, is AR-15 VooDoo. Easy, right? I mean, anybody could do this.